So today we're going to be talking about setting up an efficient profiling workflow in your project. We've got 20 minutes. It's going to be a speed run. I was very naive thinking I could do a live demo. That's not going to happen. Come see us afterwards at the booth and we'll help you out. All right. So my name is Paul. I'm a software development consultant at the Unity Montreal office. I work on the Accelerate Solutions team. Basically, in my role in this team, I get parachuted into teams that are working with Unity, and I help them out with their performance issues and any workflow issues that they might be having in their project, ultimately helping them ship their games. All right, so this is taken from the roadmap on profiling, empowering you to dig into your game's performance, identify bottlenecks, and pinpoint areas that would benefit from optimization strategies, basically stating that we have a suite of tools that you can use to quickly understand any performance issues that you might be having in your Unity project. All right, so let's talk about process. This is going to be set up in two parts. We'll talk about process quite quickly. And then we're going to briefly touch on tools. And then afterwards, if you want to get a live demo, if you have your project with you, if you want to go over any issues that you're having, come see us at the booth. I'm going to be there, and my wonderful colleagues from the same team are also going to be there. We spend our days looking at profiling data and using these tools, so come say hi. All right. So first tip, and this is pretty important, start profiling early and keep doing it throughout your production process. We have a slight tendency to keep this later on in development and only focus on performance at the very end when we're really stressed about shipping. So try and not do that. Try and start profiling from the get-go. These tools can be a little bit intimidating at first. They present a lot of data. Sometimes we don't quite know how to interpret that data. Get your hands dirty, start using them, ask questions online, reach out to us later, but start profiling as quickly as possible in your project and try put in place a dynamic where everyone's comfortable working with these tools. It's really, really helpful. Make sure that you, I often tell people, if you do playtesting sessions and you're doing this on like a 2-week cadence, try and integrate a profiling session with those playtests. Get as much data as you can throughout the production process. It's really, really helpful, and you will build more efficient systems from the get-go. All right, define budgets. This screenshot is showing the memory profiler, and we tend to think of budgets in terms of memory, but this goes for pretty much everything from memory usage to CPU usage and GPU usage, disk usage when you're shipping a binary. So first and foremost, before defining budgets, it's really great to be able to define tiers of devices that you're using. This is even more important when you're shipping on mobile because there is such a large spectrum of devices that you have to support. Defining tiers, quick example, having a tier for low-end devices, medium-tier devices, and high-end devices, depending on their specs. So once you have that defined, it's great to then define per tier, how much are you willing to spend, and let's talk about memory usage first. How much memory usage are you willing to allow for texture usage? How much memory usage will you allow for mesh usage, for your scripting layer, so on and so forth? And you can do the same exercise for pretty much all areas of importance. You can do the same for CPU. For example, on a low-end device, you might define that you want to hit 30 FPS at all times. That allows for 33 milliseconds on CPU and on GPU. How much time are you willing to spend calculating physics, running your scripting loop? Scripting loop includes, AI, combat systems, whatever you might have developed. How much time are you really willing to spend on the render loop, for example? So, this can be a little bit difficult at first just because the more projects you see, there are tendency there's things you know that you should never be spending over 6 ms on fix, but it's something that comes with experience. But the quicker you get some profiling data, the more quickly you can actually define those budgets. And it's important to enforce them, talk to your team about them, make sure they're really important. It's going to save you a lot of headaches when you actually come to the point where you have to ship. Am I forgetting anything? I think that's all right. Okay. Okay, so profile on the target device. Our suite of tools work with builds, and we support our suite of tools on all platforms. That being said, you can also use our profiling tools in the editor in play mode. And that tends to be like the easy route, and it can be very tempting, but we suggest you don't do that, just because it's going to give you a lot of false positives, and it's false data, and it's not very accurate. So ideally, what you want to be doing is profiling on device, ideally with your low-spec devices that you've defined in that previous slide when I was talking about tiers. Try work with your low-end devices first and foremost, profile on those. Then you necessarily know that if you're hitting your budgets on that low-spec device, that will necessarily translate to whatever better tiers you've defined. And then afterwards, what you could do for those tiers that you've defined, for medium and high, you can then do more stuff. So if you're actually hitting your frame budgets on a low device, you can just scale things up on your different tiers, make things prettier, make things more complex. So definitely always profile on your target device. I'll give you an example of something you should try and avoid. Specifically is using memory profiling tools in the editor. So if you've used our memory profiler, which is available on Package Manager, so the editor is two parts, right? So it's the editor itself. It supports a lot of stuff, and you can enter play mode in the editor. But we're actually going to be holding on to a lot of assets in memory that are really just editor specific. So as soon as you touch something in the project panel, we have to load those assets. They have to remain in memory for at least some amount of time. And if you're profiling in the editor, in this case, when you're profiling memory, it's going to be very, very inaccurate. So do not rely on it. Necessarily check that development build checkbox if you're using the build settings window. Otherwise, there's APIs for turning that on. That way, you'll be able to connect any profiling tools to builds that you are running on your target devices. Once again, suite of tools work on all platforms. If they aren't, open a bug, because they should be. All right, 8 minutes. Okay, trust the process. I'm going to have to zoom in on this part on the right later. I'll just start by talking about it. This one's going to take a little bit more time. So the idea here, this was a flowchart that was made for an ebook that's available on resources.unity.com. There's actually a QR code at the end of this presentation that you can scan to go to that page. So colleagues, Stephen, Thomas made like a really complete ebook about profiling. And it's like, just for example, in our team, we do a lot of profiling, and not everyone has used profiling tools. So even on our team, we have to ramp people up. And that ebook is a really, really good starting point. It covers so much stuff, and it covers process as well. And this flowchart is really important. Basically, I'll zoom in on it a little bit. Does everyone see it or not really? Is it too small? Yeah? Okay, cool. Right. So the idea is this is like a top to bottom approach to understanding where your bottlenecks are. One thing that I didn't mention in one of the first slides that I was presenting was always, at all times, rely on data to make choices when optimizing systems. Do not rely on gut feeling. Try and put all of that experience and pain from development that you've had aside, and just be like cold-hearted about it, and just get that data and figure out where your time is going. So yes, definitely rely on data, and then use this kind of approach where what we tend to do in our team when we're working with customers and creators we often get parachuted into projects that we have no idea about. And we have to hit the ground running pretty quickly. So what we tend to do is start in a Unity-centric tool like Unity Profiler, which I'll show more of later, just because it's really straightforward, easy to use, and it can give you a really good overview really quickly. So start in Unity Profiler. This is where it's going to get a little bit more complicated. You have to understand when you're trying to optimize for frame rate, that you have two limiting factors, and those two limiting factors break down into other factors. The first thing that you want to determine is whether you are attaining, so if you're going over budget on CPU or on GPU, it's always one or the other. It's very binary. So if you're running at 30 FPS, you've got a 33.3 millisecond budget on CPU and GPU. You can have the simplest system, which like a simplest CPU loop with almost like no systems running, no processing, but your project might be super render heavy and super GPU heavy. You can optimize those systems that are running on CPU as much as you want. If GPU is the bottleneck, no matter what you do on CPU will bring you no gains in terms of frame rate. So this flowchart helps you understand where to focus your energy. Start by looking at Unity Profiler, determine whether the main thread is the thread that is limiting your CPU usage or not. In Unity, this is almost entirely, most of the time this is the case. It's where all the work is being done in a Unity player, in a Unity build, or at least most of it. So determine if your main thread is the limiting factor, or a job thread might be a limiting factor. Something that's a lot less frequent. So we'll stick to the main use case, the main thread. So if you're main thread bound, we're going to go down here. We're going to use Unity Profiler to better understand which systems are running, which are consuming most time. It's nice and color-coded. It definitely helps. Spot where that issue is and focus on that first. I'm going to take a step back as well. There's two options here. You can see, if ever you see a big, massive green marker or yellow marker in Unity Profiler when you're capturing, in the CPU usage module, that almost necessarily means two things. It's either that you are bound by GPU activity or you're just waiting for vsync. But most of the time, if it's green, most of the time, that would mean that you are GPU bound. The one thing that you want to look at is if you see that your frame time is solid at 33 or 16, so respectively 30 FPS or 60 FPS, that more than likely means that you're actually hitting vsync. So if you see a massive amount of yellow, that's probably a good thing. It means that you're hitting your target frame rate. If you turn that off, if you turn vsync off, that yellow line disappears, and then you're presented with the truth, is are you really bound by CPU or by GPU? So this chart is actually in the ebook. It's really worth reviewing. It's difficult for me to go over all of it, and I'd have to take every different path, so it's not ideal. But the key thing to remember here is that you can be bound by different factors, either CPU usage, GPU usage. If you're CPU bound, are you render thread bound, main thread bound, job thread bound, or something else? But understand what your limiting factor is first and foremost, and attack that first. Because otherwise, if you go about it blindly and just optimize random systems on CPU or disable game objects randomly, you're more than likely not going to be actually helping with your frame rate issues that you might be having. 5 minutes. Okay, we're going to talk about the tools a little bit more. So let's see. So yeah, Unity ships with a range of profiling tools. It's the best place, I'd say, I'm biased, of course, but I'd say it's the best place to start looking into data. They're the easiest tools to use. They live right within the editor. So start there. We're going to go over those. But it is important to know that there are many suites of native profiling tools that are available for pretty much every platform that you're shipping on. So NDA consoles are going to have their suite of tools. Android has like a variety of them. They're often hardware vendor specific as well, so they actually break down. But yeah, all these different vendors have their own profiling tools. They are going to give you data that is completely engine agnostic. Those tools work for any engine, your own engine, no matter what. So it's really worth looking into those. We have some information in a later slide about some of them that you can use and how to learn to use them. But we're going to focus on the Unity-centric ones first, because that is really the easiest place to start. But it is the last point is really important. It's really good to combine the usage of our Unity-centric tools with platform vendor tools. They're very complementary. For example, our CPU profiling tool is an instrumented profiler, whereas tools from vendors often provide sampling profilers on CPU. So I'll give you another example. If you're looking at Unity Profiler and you have this massive amount of time spent in scripting somewhere, if you don't add any extra instrumentation code, you just see that I've got a monobehavior update that takes a lot of time, but it doesn't tell you what the actual, what function is consuming that time. So these vendor-specific profiling tools can give you more information because they have a different type of profiler that we don't provide. So very much complementary tools. 3 minutes, let's go. Unity Profiler. This has a lot of stuff. It's definitely the best place to start for diagnosing a bunch of different issues. In the screenshot, we see the CPU usage module, but actually, so you might not see, but in the top left corner, there's a profiler modules drop down. It's got a bunch of stuff in it. So it's got CPU usage, GPU usage. Just recently, we added file loading, file access, Unity UI profiler modules, physics stuff. The other part that's really good, so this third point in the slide is that it's actually extensible. If you add a package to your project called a profiling core, you can actually define counters and make your own profiler module. So say, for example, you want to know how many behavior trees are running on a specific frame. Well, you could actually add that data in through scripting and then get similar graphs shown in this screen. So it's really the best place to start. Really, really useful. Once again, works on all development builds and in the editor. And that actually applies to all of our profiling tools. 2 minutes. Okay, Profile Analyzer. This one, so the Unity Profiler comes built into the editor. You find it through Window, Analysis, Profiler, or Unity Profiler. Profile Analyzer is a little bit different. It was developed as a package, so it's available through Package Manager. It's quite complementary to Unity Profiler's CPU usage module because it gives you statistical data about a variety of frames. So it can do something that Unity Profiler can't do, which is select a range of frames and give you statistical data for this range of frames. And you can also use it to compare different snapshots or different captures or different portions of the same capture. And it relies on the data that lives in Unity Profiler. So complementary. It was developed as a package just because it was easier to release this way. So yeah, very worth getting used to. 1 minute. Memory Profiler 1.0 came out. This is the place you want to go for learning about your memory usage in your game. Get Memory Profiler 1.0 in 2022.2, the 1.0 version. Previous versions still work on all previous versions of Unity going back to 2018.3. It's available on Package Manager. It's gotten really good. It's really worth looking into, especially 1.0. Once again, works on development builds. What else do I got? This one I'm going to skip. Oh yeah, this is on 2 frames. Frame debugger. This will show you how a frame is composed. So it will not give you GPU times or usage, but it gives you really specific Unity-centric data about draw calls and batches that are composing a Unity frame, like a Unity builds frame. Window analysis frame debugger comes built in. Looks something like this in everything below 2020.2 2022.2, this is what it looks like. It's gotten a lot better in 2022.2. It's getting a lot of love, thanks to Elvar. So this tool is really useful for understanding how a frame is built. More resources. These ebooks are really, really good. You can find them here, and I'll show you a QR code afterwards. This one's really dope. Stephen Thomas wrote this one. The two others, also awesome. Start here and do those afterwards. Okay. Other stuff, Unity Learn. I put these because I wrote them. So if you want to use tools like Superluminal on Windows, it'll help you with CPU performance. It's really great. Check it out. Android Studio, same deal. It has some really good profiling tools that get you some data that's a lot closer to the middle. So definitely check those out. These guys are on Unity Learn. And thank you. And this is the QR code for those ebooks. Check them out. They're really, really nice. I think I'm 1 minute over. Cool. All right. Thanks, everyone.